Hello and good afternoon everyone. Today inshallah we will continue our journey. Today we will continue our journey and we will go through Taylor expansion. In the previous couple of sessions, we already, as you know, we started the initiation of how to deal in derivative with the functions in one variable, the functions in several variables, and the vector valuate functions, which are the functions more general to find in market problems or explaining such problems. In the previous session, we already did go through the mean value theory, which is a very important theory. It's an introduction to the optimization down the road. So it's really very important. So it's really a very important theory, and I believe we finished it in the previous session. Today I will continue with also one of the functions that's really very important. I'm sorry, the expansions that's very important in the cases of single valued functions, functions in several variables, and also we will see if we go to vector valued functions today or we will leave it for later. Of course, all of our course notes, references, you will find them on Moodle. You have plenty of exams, the midterms and everything, you will find them on Moodle. Please try to go through the midterms and try to solve some of these problems till the amount that we are in, because I need you to keep practicing all of this. All the recorded lectures, you will find them on my YouTube. As I told you today, inshallah, I will try to do Taylor theory for this session, and hopefully we will be able to finish it in today, inshallah. Okay, I will start with this formative exam. I thought we will have the time to go through it today, but due to the hectic schedule that we are in, I will postpone it inshallah next time, but I will go through it with you. Mr. Adam, since you are the one who already attended the previous lectures, let's see how to prove these equations or these problems using the mean value theory. 15. The first of them. This is e over x, e to the power of x minus 1 over x, let them e power x. How to try to prove something like this using the mean value theory. Of course, you remember that the mean value theory, it's really very simple. Do you remember it, Adam? Do you remember what we said about the mean value theory, the MTV? The MVT, the mean value theory, MVT. Yes, you are right. It's f dash c equal to f of b, yes, f of a divided by b minus a. صح؟ ده اللي انت بتقوله؟ Okay, صح. Okay, عشان to do something like this, or to go from this theory to this result, you will have to think. I will need to get where is the function and where is the interval. So the function is e to the power of x. I will consider this way. So I would consider that f of x is equal to e to the power of x. This is my first assumption. I will consider f of x equal to e power x. Then f dash x, how to get the derivative of e power x? It's gonna be e to the power of x. Now I have the function and I have its derivative. How to find the interval? I need an interval, A and B. How to get the interval? Omar, yes, it's correct. You can see e to the power of x and 1. طيب, what's the link between 1 and the exponential function? صح, yes, e to the power of 0, which means I can consider that x belongs to the interval running from 0 up to x. This is the interval that I'm going to consider. Now I have a relation. I can apply at the time being the mean value theory. I have a function, I have an interval. So all I have to do is to substitute in this guy. So I will replace f of b by e at x, يبقى e to the power of x, minus e to the power of 0, because this is a and that's b, which is going to be e to the power of 0, divided by x minus 0, which is equal to the function, the derivative, f dash, at the point c. Of course, we know that c less than x and greater than 0. It's in between this interval. Now I'm coming a little bit closer, e to the power of x minus 1 divided x, which is equal to e to the power of c. I'm coming a little bit step to this relation, that c is greater than 0 and less than x. If I consider these values as values to be put as bars of e, then I will have e to the power of c is less than e to the power of x. Now all I have to do is to replace this guy by this value. So I will have e to the power of x minus 1 over x less than e power x, and that's what's required to be proven, or this is will complete our proof. Shabab, we already solved a problem like this in the previous session, in the mean value theory, which was a proof about the logarithmic function. So once it is required, ya tara, to use the mean value theory to prove something, start from f of b minus f of a divided by b minus a is equal to f dash at c, where c belongs to the interval between a and b. Are you with me? You will need a function, you will need its derivative, you will need its values, substitute, and they give a little bit thought about c is less than b and greater than a. Then you will be able to prove your theory. Okay? Tani, once more, if I want to prove this relation, it's really very simple. All I have to do first is to choose f of x equal e bar x, f dash x e bar x. The second step, I will get x between the interval 0 and x. Of course, x can't be closed, e0 can be closed, but x, it represents that x values, so it's an open set. C belongs to this interval. The second step, f of b minus f of a divided by b minus a. Tell, can you see the whiteboard, right? Can you see it? Yes. Okay. The colors is okay. Okay. Because the glare in front of my eyes, I'm not really sure. Okay. So f dash c equal f of b minus f of a divided by b minus a. F of b, it's e bar x. F of a, which is e to the power of 0. As I told you, e to the power of 0. X minus 0, that's the relation which is connected to e bar c. Once more, c within the interval. C belongs to this interval. What's the meaning of c belongs to this interval? It's greater than 0 but less than x. This is how to get the inequality. Now I need an equality, Omar. This is how to get the inequality. Initiated. Then consider them as bars, so it will be correct to have e to the power of c less than e bar x. Just make the replacement, you are all set. Okay, let's give it another try with the second problem. This is the second problem. I need to prove that len of x is less than or equal x minus 1 and is greater than or equal x minus 1 over x. How to start? In a similar manner, just to give it a go. I will consider I need an f of x, differentiable, I need an interval. That's all I need. So I want to start with the following. Let's start with considering the f of x. I think I will consider, I'm trying f of x equal to len of x. So I will consider f of x equal len of x. Can you differentiate it? Yes, of course. F dash x is going to be 1 over x. So f dash x is 1 over x. The second step is to define the interval. Where the interval, I can go for len x starting from 1 up to x, from 1 up to x. طب اشمعنى ما بدأتش من 0؟ لأن يا آدم أنت عارف إن رسمة اللين x it will be negative from 0 up to 1 and then from 1 up to infinity it will be positive. طبعا آدم, yes, you are correct. This is the shape of y equal to ln x. No one will forget this function. Y is equal to ln of x. This is number one. So for the interval to contain x, it must go from x up to infinity. This is why I choose from 1 up to x. Do you read me? Because in this part, the function is positive. But from 0 to 1, the function is negative. So I choose the positive one. Okay? So once more, x belongs to between 1 and x. That means c within this interval. Now everything is with me. Once more, what the mean value theory? F of b minus f of a divided by b minus a equal f dash c. I will give it a try. That's f dash c equal, 1 over c equal to f of b, which is ln of x, minus ln 1, which is going to be 0, divided by x minus 1. Okay, here we go. Of course, ln 1 is equal to 0, so now 1 over c equal ln x over x minus 1. Still once more, I know that c belongs to the interval, which is between 1 and x. If you get the reciprocal of this value, you will have 1 over c less than 1 and greater than 1 over x. يبقى مجرد انك تجيب الريسبروكال هتلاقي اهي بص 1 over x is less than 1 over c less than 1. Now I will make the replacement. فاشيل 1 over c واحط مكانها دي. اهو بص ln x over x minus 1 less than 1 greater than 1 over x. عمر بص لده وبص اللي هو عايزه. ايه الفرق؟ Look to this one. The result واللي هو عايزه. He multiplied the x minus 1 all parts. So multiply x minus 1. You will have everything settled down exactly the same. X minus 1 over x equal ln x. I'm sorry, less than ln x, less than x minus 1. That's the proof that he was trying to reach. Those two problems, it's an evident that how to prove using the mean value theory. Already we had problems like this in the previous session, but I thought to give this a try if we have time. I'll give you, it would be your formative exam. Okay, back to our main topic today. Expansions using Taylor and Maclaurin for functions. I will do functions, single valued functions, as everything in this course. We start by the functions, single valued functions, then functions in several variables, then we go to vector valued functions, which is functions with more than input and more than output. Okay? So this is number one, functions of single valued functions, functions in several variables, and then from Rn into Rm, which are vector valued functions as you can see. Okay, now functions from R to R. This is the most easiest part in your course. Plenty of applications are used for Taylor and Maclaurin. يا عمر ليه الانسان بيظلم اخوه الانسان ويديه الحاجات المعفنه دي؟ لانه تايلور وماكلورين it's a tool. I can use it to expand, to approximate the value of a complicated function. بص كده, this is the function. Look to the function in blue. Okay, look to this function. This is the function. بص ادم بص شوف الفانكشن دي. الفانكشن دي شايف اللون الازرق ده ماشي ازاي؟ صح؟ بص بقى ماكلورين وتايلور بيعملوا ايه؟ او تايلور عشان تايلور جنرال كيس. تايلور هيجي لو انت عايز تعمل اكسبانشن of 1 degree or of 1 polynomials of first degree, okay, degree واحده هيبقى straight line. بيحاول يدور, we are trying to reach the nearest straight line to the actual point. This is how I'm going to approximate. طيب, if I raise the degree, I can be talking about a polynomial from the second degree in order to find a point also very close to what I want to find the exact value. So actually, I don't have the exact value of the function, but I'm trying to use plenty of polynomials. A first degree polynomial and see is it very close? A quadratic, a cubic, a fourth degree, a fifth degree. So I'm playing with the polynomials to reach the best one of them to approximate the value at this point. This is why Adam we usually find the Maclaurin or Taylor in the neighborhood of a certain point. يعني انا بعمل expansion جنب point. Okay, I can use the equation for the neighborhood للبوينتس اللي جنبها. معايا؟ دي الفكره الاساسيه. طبعا ده المين ايديا اهو، دول كلهم approximating polynomials. It depends on the degree of your expansion. طبعا هنا بيقول لك these expansions are used to approximate the value of the function at certain point, valued by various types of polynomials and of various degrees. This is why we usually find the expansion at certain point in the neighborhood of a particular point. يبقى انا عايز اوجد الفاليو عند نقطه محدده، بوجد particular point، اجيب الاكسبانشن عندها واستخدم الايكويشن. معايا؟ طيب جميل جدا. طبعا ده الانترودكشن بتاع تيلر بقى خلاص، ده اللي انا عايزك تحفظه. الفكره بتاعت تيلر انك لازم تعرف الاكسبانشن وتبقى ميمورايزنج اللو بتاعه. اللو بتاعه سهل قوي. بص هو ماشي على سكه، يعني I need to expand f of x. I need to expand the function f of x in the neighborhood of certain point. بص كده بالستار الفاليو بتساوي approximately the value of the function, value of this function at the point that you are using, then plus x minus a times f dash a, then plus it's like a train. The second, the third term, it's going to be x minus a to the power of 2 times f double dash at a divided by factorial 2. Do it once more. Then plus x minus a to the power of 3 times f triple at a divided by factorial 3. Then continue x minus a to the power of 4 f 4 times the derivative of a divided by factorial 4 and so on till you reach x minus a to the power of n divided factorial n times fn at a. This is the general law of your expansion. ماشي؟ طبعا خلي بالك سهل جدا. f of x دي اول واحده equal f of a the value of function at point. بعدين differentiate the function and get the value times x minus a. بعدين differentiate the function once more. بعدين start substituting. تشوف دلوقتي على problem you will never forget it. It's very very simple. This is what's called Taylor's expansion. يبقى ده Taylor expansion. Maclaurin expansion, it is exactly the same. Exactly the same. But not using any point, using the origin. يبقى Maclaurin هو نفسه تايلور بس بدل الاي دي ومستخدم البوينت اللي هي فين؟ زيرو. يعني substitute بايه بزيرو. طبعا ده اللو هنا Maclaurin اهو زي تولجر يبقى اف اوف 0 دي بقى لما تبقى اكس ماينس اي تو ذا باور اوف 0 يبقى اكس تو ذا باور اوف 3 دي بقى لما تبقى اكس ماينس اي تو ذا باور اوف n is gonna be x to the power of n and so on. ده Maclaurin expansion. ده short written summation. Instead of writing all of this, I can write the sum from n equal to 0 up to infinity of f of n at a divided by the factorial of n times x minus e to the power of n plus a remainder term. The remainder term is required to make the left hand side exactly equal to the right hand side. Are you with me? If I didn't wrote the Rn, then they will be approximately equal to each other. معايا يا شباب؟ Okay, that's the main laws in this book. That's the law of the function, and this is how can we write it as a polynomial. خلي بالكم as a polynomial. That's how to write it as a polynomial in the neighborhood and the degree, because I can find a polynomial from first degree, a polynomial from second degree, a polynomial from third degree. طب polynomial first degree يبقى شكلها عامل ازاي؟ مسألة f of x بتساوي f of a plus f dash x minus a right inverse. ده first degree. طب second degree يظهر البراكت to the power of 2. طب third degree يظهر البراكت to the power 3 and so on. ماشي؟ معايا يا شباب؟ اوكي خلي بالك من معلومه مهمه قوي. بص تقع من فوق. لا مهمه قوي. تقع جدا. بص f dash a times x minus a هي السيمبل ده. اللي بالك انت بتلعب في الموبايل ومش باصص. وده ما ينفعش لسبب مش هتفهم. خلي بالك ان اف داش اي في اكس ماينس اي يعني التو تيرمز دول على بعض كده اقدر اشيلهم، يعني دول كده اقدر اشيلهم كده كلهم واكتب مكانهم دي اوف اكس ماينس اي. يعني ممكن يا اما اكتبه بدلاله اف داش اي في اكس ماينس اي، يا اما اكتب بس ايه دي اوف اكس ماينس اي في مين؟ دي علامه ديريفيتيف في اف وفي. طب بص طبعا الجايه دي انا ممكن اشيل دول ده كده واكتبه دي اوف اكس ماينس اي ثيرد ل اف اوف اي divided by factorial 3. فمهم انك تبقى فاهمه لا يلخبطك. يبقى انا ساعات بكتب بدلاله الدي وساعات اكتب بدلاله مين؟ الاف. ده موجود في التكست بوكس. ده هينفعني بعد كده لما اتكلم على فانكشنز سيفرال فاريبلز. اتفضل يا فندم.
هو الحاجات دي هتبقى جيفن مع الامتحان؟
لا حضرتك تحفظها.
ماشي.
انت صغير. اوكي؟ يبقى ده حلو جدا. حلو جدا. اي مشاكل ثانيه؟
زي الفل.
ما خدت بالك انت من الخدعه دي؟ خدعه خطيره خلي بالك. طيب حلو. تايلور بولينوميال ده الشكل العام اهو، ده بقى اللي انا بكلمك فيه. This is تايلور بولينوميال بس من انهي ديجري يا ادم؟ لذلك ظهر فيها دي اكس ماينس اي. تقدر تكتب لي تقول لي دي اكس ماينس اي ده هو مين يا عمر؟ ها ده عباره عن اف داش اي في اكس ماينس اي. شايف؟ ما هو ظهر القوس تو ذا باور كام؟ واحد. طب لو هي باور 2 لو باور 2 لو بولينوميال فروم سكند ديجري هزود ترم، في ترم كمان يزيد. بص سكند ترم زائد هنا دي اس كام؟ دي تو ذا باور اوف كام؟ 2. تقدر تفكها؟ عارف هي مربوطه بمين؟ ها اف دبل داش اوف a times x minus a to the power of كام؟ 2 divided by factorial 2. دي اللي انت شايفه تحت ده. لاحظ ان ده بولينوميال من انهي ديجري؟ سكند. لذلك ظهر عندك براكت to the power of 2. طب لو انا عايز اجيب بولينوميال اوف ثيرد ديجري يبقى هزود كمان ترم نفسه بالظبط، هيبقى اف تريبل اكس ماينس اي تريبل على فاكتوريال 3. سهله جدا اهو. ده اوف 3 شايف؟ طب لو عايز افتحها يعني تروح للان يبقى اذا الجنرال ترم يتكتب ازاي الجنرال ترم؟ انت تعرف
زود اكيد.
واحد على فاكتوريال ان في دي ان اوف اكس ناقص اي اوف اف اوف اي، اللي هو لو حبيت اكتبه زي دول اكتبه ازاي؟ يبقى الكتب كده اف ان اي يا ادم في اكس ماينس اي تو ذا باور اوف ان على فاكتوريال ان. لازم اربطهم كده يا ترى، ولازم استخدم قلم. لو ما كتبتش بالقلم مستحيل تفتكره، مستحيل. اوكي زي ما حضرتك شفت طبعا اقدر اجنرالايز ات. اللي انا بعمله ده تايلور ولا ماكلورين؟ اللي انا كاتبه ده تايلور ولا ماكلورين؟ تايلور. طب ماكلورين يفرق ايه؟ مكان الاي زيرو. يعني تخيل في اثنين دخلوا التاريخ، تايلور دخل ماكلورين دخل. تايلور دخل بانه بيفك حوالين الاي، ماكلورين دخل انه بدل الاي جنرالايزد عن سي. طبعا ده الديجري كي، ده الشكل العام زي ما انت شايف الكي ثيرد. طيب لو انا بتكلم طبعا انا كاتب لك دي على طول باستمرار لان انا عارف هتتنسي هتعمل مشكله بدون ضروري. طبعا ده الشكل بتاع ماكلورين سيم السلايد اللي فات بالظبط، بس الاونلي ديفرنس instead of dealing with A I'm dealing with a zero. معايا ادم؟ تمام؟ طيب انا هحل دي بسرعه. بصي كده لان دي سنجل فاليود فانكشن فحلها سهله. لو انا عايز يعمل ايه؟ عايز تايلور. تايلور بتاع مين؟ بتاع اي باور اكس. عندي مين؟ عندي اكس بتساوي 2. اوكي؟ اب تو ذا انس تيرم. بص راح جاي كاتب كده اف اوف اكس equal e باور x. f dash of x يساوي كام؟ f double dash of x يساوي كام؟ f triple of x هيساوي كام؟ لغاية f n x هيساوي كام برضو؟ let's insert x بتساوي 2. يبقى انا بفك at the neighborhood of x بتساوي 2. مليني كده يا تلاتة. f at 2 يساوي e باور 2. f dash at 2 يساوي كام؟ f double at 2 e باور 2. f treble at 2 يساوي e باور 2. f n at 2 بتساوي e to the power of 2. صح؟ الستيب اللي بعديه apply the law. Do you remember the law ادم؟ f of x او خليه هكتب f of x او اكتب polynomial of x of power n for the function f equal to. I will start f at a plus f dash a x minus a plus f double dash at a x minus a to the power of 2 by factorial 2 blah 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 plus x minus a to the power of n f n a divided by factorial n plus the remainder term. All I have to do is to substitute. So this is going to be e to the power of x equal to e to the power of 2 plus e to the power of 2 times x minus 2 plus e to the power of 2 times x minus 2 to the power of 2 divided by factorial 2 plus e to the power of 2 x minus 2 to the power of 3 divided by factorial 3 blah 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 plus e to the power of 2 x minus 2 to the power of n by factorial n plus the remainder term. صعب؟ ها؟ صعب؟ دي function derivatives substitutions write the law substitute steps. تعبيط ده مفيش حاجه احنا بنعملها فيها steps. دول بقى ماشيين ايه؟ steps ورا بعض. اوكي؟ طبعا I've already sent you changed the I think one of our companions changed the name of algebra into calculus 2 and I think he added most of you. Are you added on our group? Okay, very good. I think I sent this PDF. بص عليه كده يا ادم الPDF ده عندكم؟ انا بعته امبارح. ها؟ شوفوا بالله. اهو. طبعا ده اللو بالقانون بتاعه. دول الديريفاتيفز هنا الاف اوف اكس الاف داش الاف دبل الاف تريبل سو اون. هنا بحط اكس ايكوال تو 2 جبت الفاليوز بتوع الديريفاتيفز. عملت substitution. Here we go. That's the substitution. Exactly like the one that I told you. In a similar manner, I can do a lot. I can do for e power 3x sin 3x معايا هذا. I can do ln x plus 1. I can do e to the power of negative x. All of this are solved, so I'm not going to lose time in just going through it. Just simply you will have step number 1, write the function, differentiate, substitute, then substitute it, write the main law and substitute in it, and you are done. معايا Adam? Okay? Any questions? Okay. I've already expanded most of them for you. All of them. Just the training exactly the same, I'm just changing the function and its derivatives. But it is exactly the same. So there is no problem in all of this, it's okay. Those are the famous expansions, Maclaurin expansions for general functions. It is already expanded previously. This is for e of x, e power negative x, sin x, cosine, sine, len. The expansions are important because I can, instead of, if I have a program, a computer program, and I want to enter a value of these functions, it will be very easy to enter the main law or the main polynomial, which is a polynomial, to the computer, and he will do, or your calculator, and he will do the repeated calculations very fast, and you will get an approximate value, but actually it's very close to the exact one. Are you with me? Okay. Continue. I can find also Taylor Maclaurin and use them to approximate values. That's an example of how to use them. For root 5, I will do the expansion for root x, for example. So I will get f of x, f dash x, f triple x. This is f of x, which is root. Do you know how to differentiate root x? Huh? I was not a saying. So f of x equal to x to the power of
negative.
يبقى f dash x will equal to half x. طيب if double dash of x half times negative 1 over 2 times x to the power of. طيب can you get f triple? Half times negative half times negative 3 over 2 times x to the power of negative 5 over 2 and so on. Am I right? Then I will start to use, he needs you to approximate root 5. I can do the expansion, what's the nearest number to root, to 5 that you have a square root for? What's the nearest number to 5 that you can find a square root? 4. So I will get the expansion around 4. Then I will substitute by 5. بص كده المسألة. But insert x equal to 4 in each one of them. لما تحط x equal to 4, this is going to be f at 4 equal to f dash at 4 equal a quarter. F double dash at 4, it's going to equal to negative 1 over 32. F triple at 4, it's going to be 3 over 256. Of course, in the exam, you are not going to have problems with a lot of numbers. Do you understand what I'm saying? But it's the same matter. Okay, continue. So f of x equal to f of a plus f dash x, x minus a, and so on. I will use a equal to 4. This is what I told you. Then make the substitution. You need to find root 5. Am I right? Replace every x by can by 5. You will be able to get the value. Here we go. Insert x equal to 5. Then you will be able to approximate your value. Of course, for us, it takes a lot of work. But if you insert this equation into a computer or into algorithm, if I replace x with 7, you will evaluate it. X was 9, you will get the value. X was 11, you will get the value, approximate value. Are you with me? Just replacing every x by the number. So this is why we are using the expansion of Taylor and Maclaurin, and they are very important for us in order to approximate the values. Adam at 1:50, let me know. What's the time now? 1:10? Okay. Let's go for sine 31. It's exactly the same, but so I will scan it. You already have the solutions for it and everything, so no problem. Thank you. Ken Reeves. Find the Taylor polynomial of degree 2. خلي بالك دي مسألة امتحان. Find the Taylor polynomial of degree 2, which approximates the function defined by e to the power of 2x in the neighborhood of x equal to 1. تعالى تعرف تحل دي؟ لا دي بص فكر هو مين الفانكشن؟ ها بصي انت e to the power of 2x. طيب الفيرست ديريفاتيف هيبقى e to the power of 2x times 2. طب السكند ديريفاتيف هيبقى e to the power of 2x times another 2. طب الثيرد ديريفاتيف e to the power of 2x times another 2. Okay, he don't want you to do it to n times. He just wants you to expand it till degree of 2. Second degree. So you will have the first derivative and the second, and substitute in the equation till the second term, which contains x to the power of 2. So all I have to do, this is the function which is e to the power of 2. This is the derivative of function, which is 2e to the power of 2x. This is the second derivative for e to the power of 2x. Replace every x by 1. So this is f dash at 1, that's f double dash at 1. I have the three values at 1, f dash at 1, f double dash at 1. Use them to substitute in the expansion. That's the expansion. replace f1, f dash 1, f double dash 1 times x minus 1 times x minus 1. Are you with me, Mr. Adam? Okay, make the substitution. That's the equation simplified. How to simplify it? I will take e to the power of 2 as a common. Then I will multiply 2 times x, 2 times minus 1. I will expand this bracket, which is x squared, the first square, first, second times 2, and the last square, which is 1. يا آدم، أنت مركز معايا؟ ماشي معايا؟ طبعا دي الايكويشن بتاعتي اهي افضل approximation. I have the polynomial of how many degrees? Second degree. طبعا معنى ان السكند degree لازم يبقى عندي x to the power of 2 already. خلاص اوكي. طبعا ده الشكل. بص بقى بيقول لك ايه؟ ده شكل e to the power of 2x. اهي ده شكل e to the power of 2x. مش انت عايز ابروكسيميت الفاليو ات اكس بتساوي 1؟ بص يا تلك ات اكس بتساوي 1 انا طالع دي الفاليو اون ذا مين فانكشن، دي الابروكسيميتد فاليو اللي بالازرق. شايفه الاثنين قريبين من بعض ازاي؟ يكاد يكونوا فوق بعض. يبقى انا instead of dealing with the exponential function بقيت بستخدم quadratic function. يبقى بدل ما كان عندي exponential عند النقطة دي استخدمت مين عشان اوجد الفاليو؟ كوادراتيك اللي هي بولينوميال اوف ديجري اوف سكند ديجري. ار يو ويز مي؟ كمان اهو طبعا ادي الاف اوف اكس وادي الفاليو بتاعت الابروكسيميتد فانكشن اخر حاجة. تيلر ريميثر الفانكشنز. لو انا كتبت يعني بص ده الفاليو دي مش الفاليو دي ابروكسيميت يعني تقريبيا لمين؟ لده. طب امتى تبقى اكزاكت؟ عشان كده هو لما جه يكتب ما كتبش اف اوف اكس، كتب بولينوميال. لكن لو انا عايز اكتب اف اوف اكس يعني عايز اقول ان دي بتساوي اف اوف اكس يبقى غلط. لازم اقول دي بلس ار ان. ريمبر ده عشان تبقى الايكواليتي ساين will exist. يبقى انا دلوقتي محتاج اتكلم على الاريتر. I have to identify the error of Taylor expansion in single valued functions. This is why we are going to go to this part. It's not complicated, it's really very simple, and it's related to the general term of Taylor expansion. So once more,